Good morning to one and all present here. Today, let us see about a topic called convection in heat and mass transfer course. In general, the convection is a mechanism of heat transfer through the fluid in the presence of a bulk fluid motion. The convection heat transfer is made up of two mechanisms. One is energy transfer due to random molecular motion, that is diffusion, and second one is by an energy transfer by a bulk or macroscopic motion of the fluid. In the other terms, the convection is defined as when the heat transfer occurs at a different medium is called a convection. One is by a solid surface and another one is by a fluid. This convection amount of heat transfer can be classified into two types. One is forced convection. The second one is called a natural or free convection. Let us see what is forced convection mean. The fluid motion is artificially created by means of an external forces like blower or fan. Such type of heat transfer is known as forced convection. And second one is called free or natural convection. It means when the fluid motion is produced due to change in density resulting from the temperature gradient. Such mode of heat transfer is said to be free or natural convections. So these convection mode of heat transfer can be defined in Newton's law of cooling. So it states that the convection heat transfer flux is directly proportional to the temperature gradients. Therefore, Q is directly proportional to delta T. Therefore, the Q by A is proportional to delta T. In order to remove this proportionality, we introduce a constant called an H, that is a heat transfer coefficient. So therefore, the final equation became Q is equal to HA into delta T, where H is the convection heat transfer coefficient, area is the A is the surface area, delta T is the temperature difference between the two mediums. So now let us see about what is a heat transfer coefficient. So it can be defined as the rate of heat transfer between solid surface and fluid per unit surface area to per unit temperature difference. Therefore, QH is equal to Q divided by A into delta T. So this heat transfer coefficient strongly depends on fluid properties such as a dynamic viscosity and a thermal conductivity, density, and specific heat and velocity. And these properties we can refer it from HMT data book, depends on the fluid force. Now let us see about what are the various numbers we are going to study in a convection unit. First number will be a Nusselt number. It is denoted by Nu, and it can be defined as the ratio of the convection heat transfer rate to the conduction heat transfer rate across the same fluid layer. Therefore, Nu is equal to Q convection divided by Q conduction. We know what is convection formula, HA into delta T. What is conduction formula means from Fourier's law of heat conduction, Ka into dt by dx. So by substituting this equation, by cancelling the same data parameters, the final equation of Nusselt number is HL by K. This HL by K is the Nusselt number formula when we are dealing a problem on a flow through plates. When we are solving problem on cylinders or spheres, the formula became HD by K. So what is the significance of Nusselt number means? So in order to know the fluid properties and also the heat transfer coefficient, we need to solve the Nusselt number value. And the second number will be a Reynolds number. So this Reynolds number can be defined as the ratio of inertia opposed to the viscous force. So by substituting the inertia force and viscous force values, the final equation of Reynolds number is UL by gamma. And this is the Reynolds number formula when we are solving problem on flat plate. If it is a tubes or sphere, the Reynolds number formula is become UD by gamma. That is the instead of here, we are substituting a term called D, that is the diameter of the tube. So and also this is the critical Reynolds number values for a flat plate and subduct pipe. For a flat plate, the critical Reynolds number is 5 into 10 power 5. So the value is less than 5 into 10 power 5, it is a laminar flow. If the value is greater than the 5 into 10 power 5, then the flow of the fluid flow will be a turbulent. And also when we are solving problem on circular pipe, the Reynolds number for a critical value is 2300. So the same like previous term, if the value is less than this one, this laminar flow is greater than the 2300, is a turbulent. So we need to find the Reynolds number value whether we need to know the flow will be a laminar or turbulent. And third number will be a Prandtl number. So the Prandtl number is defined as the ratio of momentum diffusibility to the thermal diffusibility. So by substituting the momentum diffusibility to thermal diffusibility terms, the final equation becomes gamma by alpha. That is the Prandtl number equation. And the fourth number will be a Grashof number. This Grashof number is defined as the ratio of product of inertia force to the buoyancy force to the square of the viscous force. By substituting the suitable values of inertia force, buoyancy force, viscous force, final equation becomes GR is equal to G into beta L cube into delta T divided by gamma square, where G is the acceleration due to gravity, the beta is the thermal expansion, and the L is the length, and delta T is the temperature difference, and the gamma is the kinematic viscosity. So this is the equation when we are solving problem on flat plate. We are solving problems on a circular tube. Instead of L, we need to substitute a term called a D, that is the diameter of the tube. Therefore, GR is equal to G into beta into D cube into delta T divided by gamma square is the equation of a Grashof number when we are solving problem on circular pipes. Okay. And the next number will be a Stanton number. The Stanton number is defined as a Nusselt number to the product of Reynolds number and Prandtl number. We know what is the Nusselt number final equation, Reynolds number final equation, Prandtl number final equation. By substituting these equations, the final equation of Stanton number is equal to H into rho into U into Cp, where H is the heat transfer coefficient, rho is the density of the fluid, U is the velocity of the fluid, and the Cp is the specific heat of the fluid. So these are the various numbers we are going to deal when we are solving problems on a convection mode of heat transfer. And next will be what is Newtonian fluid and what is non-Newtonian fluid. When the fluid will obey a Newton's law of viscosity, it is called a Newtonian fluid. When the fluid does not obey the Newton's law of viscosity, it is called a non-Newtonian fluid. What is Newton's law of viscosity? Means it states that the shear stress between an adjacent fluid layer is proportional to the velocity gradient between the two layers. The shear stress between the two layers is always directly proportional to the velocity gradient of the two layers. That will be given in a law called a Newton's law of viscosity. If it obeys a Newton's law of viscosity, then the fluid will be called a Newtonian fluid. If it does not obeys the Newton's law of viscosity, it's called a non-Newtonian. Okay. And next term will be a laminar flow. What is turbulent flow? We know we already studied in an FMM fluid mechanics subject itself. When the fluid flow follows a smooth and continuous path, it is called a laminar flow. If the fluid follows an irregular path, is called a zigzag movement, is called a turbulent flow. So the turbulent flow will always having a higher velocity compared to a laminar flow.